Anderson, and today we'll be discussing the 4 fundamentals of flight. 4 fundamentals of flight are thrust, lift, weight, and drag. When in straight and level flight, an unaccelerated flight, all the 4 forces are in equilibrium. The first force, thrust, is provided by either a propeller or a jet turbine. This is a process of combusting fuel to either power a piston or turn a turbine, thus producing thrust to pull the aircraft forward and creating more air to the leading edge of airfoil, which leads into our second force, which is lift. Lift is a process of the relative winds striking the airfoil, and when they strike the airfoil, lift is always perpendicular to the relative wind. So if it was in straight and level flight like so, with relative wind striking the chord line straight, the force of lift would be straight up, thus bringing the airplane up. You can control the force of lift by either altering your control inputs by changing the angle of attack, thus your airspeed is reduced but it increases your altitude, or you could increase the power. Going to full power would create more lift under the wings to lift you up. The other principle that allows lift to happen is Bernoulli's principle. Bernoulli's principle, you can see here on the board, with the relative wind striking the airfoil at the chord line, it splits the air molecules in two. The ones on the bottom, they are slower moving air molecules, while the ones on the top are faster moving. This process creates an area of high pressure underneath the wing, creating a force that's pushing up on the wings, which creates lift. The third force, there's 2 types of drag. There's parasitic drag and induced drag. Parasitic drag would be any flaws on the body of the aircraft slowing it down. On the planes we fly, they have a ton of rivets in them. That could be one cause. Landing gear, we don't have retractable gear on aircraft. That's a big cause of parasitic drag. Induced drag is drag that is created just by the edges of the body that create lift to help lift the airplane, such as the leading edge of the airfoil. Obviously that'll have some sort of drag. The nose of the aircraft, the whole body of the aircraft will have some sort of drag that will slow the aircraft down, but overall the lift created will outweigh the drag. A good example of this is if you stick your hand out of a moving car that's going, say, 60 miles an hour, with your hand perpendicular to the relative wind, your hand will be slicing through the wind, creating the least amount of drag possible. As you change the angle of your hand, you're going to be allowing more surface area for the wind to catch, and your hand will move backwards. Same example is if you start pitching the airplane forward, you'll have more force on the bottom of the wings, slowing your aircraft down, creating more lift, pulling up. The last force acting on the aircraft is weight. Weight is equal to mass times gravity, meters per second squared. They do this because you have the gross weight of the aircraft, and then you have that weight times the gravity. So here on Earth it's 9.81, and that's all acting to pull the aircraft down to the ground. There is a certain amount where the aircraft, it differs by aircraft to aircraft, but there's a certain weight where the aircraft will not be able to provide enough substantial lift to get it off the ground, thus resulting in your gross weight being over the specified amounts in the POH. So that's why it's important that we do our weight and balance before every flight.